We're going to carry on with our lesson on science, conductors and insulators today, and I've got a little experiment that I've got set up on the table for you to demonstrate what exactly conductors are, what resistors are, and what insulators are. I'm also going to explain very briefly what a switch does in a circuit and how we can tell that a circuit is running, or in other words, passing electricity through it, so that we know there is electricity on. Just remember that electricity is not something to be played with. The voltages that I'm using here are very, very small, 1.5 volts, and the amps, which is the amount of electricity that is flowing, is very, very, very low. Electricity can kill you. It can interrupt the electrical signals between your brain and your heart, and that is how you can be killed by electricity. Now, just to put it into perspective, half an amp of electricity can stop your heart. That is the same amount of electricity that is coming out of your cell phone charger. It might have 5 volts coming out, but the rate at which that electricity is coming out, it is at a rate of 1 amp. We'll talk a little bit more about amps and currents when you're back in class, because it's a little bit more complicated to explain, because there's no demonstration that I could do to show you that. But I do have a practical way that I could show that to you. So just bear in mind, I don't want you touching wires to your tongue. I don't want you playing with batteries and doing silly things with them, because you could hurt yourself. I hope you enjoy the experiments that I've got set up for you here. Please make your notes as you go along. Pause, rewind as you need to. You won't be able to do these experiments right now, but when we do come back to school, I will set these up, and there's enough equipment here for you all to do it. Because what I will need you to do when you get to school is to actually build your own battery. So this is the beginning of it. We're going to end off this week talking about conductors and insulators, and when we come back to school next term, that is where we'll be able to do the practical side of this, where you get to do the experiments also. The first thing is, for our circuit, we will need a power source, and this power source in the form of batteries. Now these batteries have a voltage of 1.5 volts each, which means together, you add up that voltage, there should be about 3 volts coming out of these batteries. And what we're going to be using for conductors are a couple of crocodile clips. I'll use the red crocodile clip to show where the positive charge is, and I'll use the black where the negative charge is, or maybe I'll change this to green rather. And I'll use these green cables to show the negative charge. We have our batteries, we have our conductors, and we're going to use a switch. Now the switch that you might be used to is something like this. You've probably seen this at home. However, for this experiment, I'm not going to wire this one up. We're going to use a switch like one of these Frankenstein looking switches. This is exactly what a switch does. All it would do is you'd have your connections at the back, okay? And when you throw the switch, you're closing that connection. So electricity would flow from a wire that's going in there, through that post, through the switch itself, out through that post, and then out through the other wire. So all the switch is going to do is open and close our circuit. To help us understand what's happening with our circuit, I'm going to be using a buzzer. And this buzzer here will emit a sound, a high-pitched squeaking sound, when a current of electricity is passing through it. That will let us know that there is electricity flowing through our circuit. We can also use this guy. This is a little 1.5 volt light bulb, and this will obviously be very bright because we're going to be pushing 3 volts through him. And what this will do is also show us that we've got a complete circuit running. And this weird looking fellow over here, this is called a variable resistor or a potentiometer. And what this does is it's got a little circuit of its own on the inside, and there's a contact that runs around the circuit, and as you turn the dial, you're making that circuit longer, basically increasing the amount of distance the electricity's got to run through. That increases resistance, which makes the electrons of electricity flow slower. And we're going to experiment and see how this affects the flow of electricity. And this is it. This is the equipment that we're going to set up for today's experiment. I hope that you'll be able to follow along and complete the notes as we will proceed. And so here you can see our switch is now connected. we have our circuit running from our battery, and when I close the switch, you see the light comes on. So this shows us that we've got a complete circuit running through our conductors right now. Now what I'm going to do is I'm going to wire in the buzzer and also the variable resistor, and we're going to experiment to see what happens to the light as we add things to it. So now here we've got the buzzer connected. I'm going to throw the switch, I'm going to turn it on, and you're going to see what's going to happen when I close the switch and the circuit flows. So this is interesting. Just by adding the buzzer to our circuit, we have caused enough of an interference of the flow of electricity that the light can't light up. However, if I had to short circuit this, in other words, disconnect the buzzer and bring it straight over to where the light is, we see that the light is still working. So just by adding this to the circuit, it's using enough electricity for there to be none left over for the light to light up. Okay, and now I've connected up our variable resistor, our potentiometer, and I want you to notice what's going to happen to the light when I slowly turn the dial and increase the resistance of this. See that? It's obviously resisting the flow of electricity more and more, and if I turn it up all the way, the light goes off. Turn it up again slowly. You can see the electricity is flowing enough to make the bulb light up. Now the interesting thing about a light bulb is that it is itself a type of resistor, and if you had to look at this very, very closely, you would notice that there is just a coil of wire inside it, and as you increase the electricity flow, that coil of wire resists the flow of electricity to the point where it begins to glow red hot. If I turn it up even more, it begins to glow white hot. And so we are here changing the flow of electricity, into another form of energy, which is light and heat. And this is now electricity being used up. If we had to disconnect all of these things and just connect the batteries to themselves, that is what we would call a short circuit, because electricity is actually not flowing in and being used anyway. It's just being pumped out of the battery back into the battery. We are allowing more electricity to flow through the circuit, which gives us a brighter light. But if we restrict the flow of electricity, restrict the flow of the electrons, you can see that there is a very, very dull glow on this light. Okay, so here we're going to be testing the conductivity of various materials. Conductivity, that means how well an object can allow electrons to pass through it, how well it can conduct electricity. So I've got a few things set up here. Excuse the messy setup. I have got a pencil with graphite lead in it, wooden stick, popsicle stick. I've got a metal ruler, metal screwdriver, the plastic handle, a rubber eraser. Now just to show you that there is electricity flowing through here, I'm going to just put the circuit together straight away and turn the switch on to show that we do have our circuit running. And then one by one I'm going to disconnect the circuit and I'm going to test each object in our experiment. The first one that we're going to test is our eraser. What's your prediction? Do you think that this is going to resist the flow of electrons, or is it going to conduct the flow of electrons? Is it going to insulate? Insulation meaning, is it going to slow down or stop electricity from flowing through it? Is it going to be a resistor? Let's connect it up and find out. Pretty obvious, I'm sure you all know. Rubber does not conduct electricity. Our light is not on. Just to confirm that the circuit is running, I'm going to touch this crocodile clip to the other side to show that our light is running. But rubber itself is an excellent insulator. This is the reason why when people are working with electricity, you'll find that they'll wear rubber gloves or they will actually wear rubber boots. The next thing that we're going to test is our metal screwdriver. I'm going to connect the front up here and I'm going to connect the back, just touch it to the plastic. And again, you can see that there is no circuit, the light is not coming on, which is the reason why screwdrivers are made with plastic handles, particularly these kind that are used for electrical work. It's so that any circuits that you might touch by mistake, you are not going to be having any of that current flowing through you. So if I had to connect the crocodile clips straight to the metal of the screwdriver, we see that current does flow. So this is stainless steel and it does allow electricity to flow through it. The next thing that we're going to test out is our metal ruler, which again is made out of steel. But there's something interesting that I want to show you on this here. So if I touch it to the steel, the light lights up. If I touch this contact to the paint on the steel, the light goes off. And if I run the contact over the numbers, you see how the light flashes as the crocodile clip goes over the numbers. So the paint itself on this ruler insulates and does not allow electricity to flow through it. The steel itself clearly does. The wooden popsicle stick, what's your prediction? Is this going to conduct or is it going to insulate? It's pretty obvious. Also, wood is an excellent insulator. Electricity does not flow through wood. And so now I leave this one as the last one. What is your prediction for the pencil? Do you think it's going to conduct electricity or insulate it? I'm going to connect it to the wood to start off with, because we know that wood does not conduct electricity, no light. However, the substance that the pencil is made with, the graphite, does conduct electricity. And this is the reason why when there's lightning about, golfers need to take cover and fishermen need to take cover, because our golf clubs are sometimes made from graphite and our fishing rods are made from graphite. And if you look carefully, there is a very faint glow. It's not as bright as the others have been, but it does show that there's a certain amount of electricity flowing through the graphite core of this pencil. It's an ordinary HB pencil and it conducts electricity. So that is it. I hope that you've enjoyed those experiments. I'm very sorry that you haven't had the opportunity to do these experiments yourself, but when we come back to school, as soon as we're able to, we will set all of these experiments up and you'll be able to do them for yourselves in your groups in the classroom. Until then, I hope that you are able to understand the setup that I had here. It's not the greatest. It was a bit awkward trying to do stuff right in front of the camera. The wires were misbehaving. They just didn't want to obey what I wanted to say. But you have the idea. Conductors and insulators are all part of an electrical circuit. And if there is a flow of electricity, we know that the conductors are working well. If there isn't a flow of electricity, it's basically telling us that there's either a break in the conductor or along the way we've got a resistor that is resisting the flow of electricity. We use insulators where we need electricity to flow, and at the same time we try to protect ourselves from the flow of electricity. We've got electricity flowing on the insides and we have got insulation on the outside so that when we handle this wire, we don't feel the flow of electricity in our bodies. I hope you enjoyed the lesson and I look forward to seeing what your notes look like.